I have read that the first alcohol stove we know about was developed around 1850 by a mountain climber. Alcohol stoves have certainly got a lot of use since then, and I am a big fan. Such a big fan that I have 2 Trangias, and I made a handful of homemade alcohol stoves. Then one day I was at a wooden shelter on the Appalachian Trail, and I saw a thru hiker pull out 2 items that looked just like this. A piece of heavy aluminum foil and what looked like an empty tuna can. He assembled it like this, put some alcohol in, and lit it. My first thought was, you gotta be kidding me. After he cooked his meal and ate, it occurred to me that what he did really wasn't too much different than using a can of sterno, but he had a hotter flame than sterno, which we'll talk about later. Later, I ran into a couple of other thru hikers using plain open cans as alcohol stoves. One of them told me he decided to send his white gas stove home and switch to alcohol. And as you can imagine, he said it was easy to find a can to use as an alcohol burner. So if nothing else, an alcohol stove like this is an expedient on a long trail like the AT. If a hiker decides in mid-hike to switch to alcohol, a stove like this will work. Compared to information available about more sophisticated alcohol stoves, information about using an open can as a burner is something that is discussed only infrequently. For that reason, we're going to take a detailed look at stoves like this to answer the question, how well do they work for a long-distance hiker on the Appalachian Trail? We're also going to give you some ideas on how to put together an expedient alcohol stove if you ever need to. Now, the typical discussion about alcohol stoves begins with boiling water, and that is where we're going to start. Here's a little experiment that you can do at home. Put about 24 ounces of water at room temperature in a pot. Put a cooking thermometer inside the pot with the water. Put it on your electric or gas range, positioning the thermometer so it won't be affected by any heat from the burner. And starting with that essentially cool water, turn the stove on and watch the thermometer as the water heats up. Here are the results I got indoors at 75 degrees at sea level. Even at room temperature, steam is visible at 140 degrees. By 170 degrees, the first bubbles appear. The intensity of the bubbles increases with every 10 degrees in temperature. By 190 degrees, the bubbles can be seen pretty handily at the surface. And from there, it gets hotter until we reach the full rolling boil of 212 degrees Fahrenheit. If you do this experiment, say, at 5,000 feet above sea level, you will get a different result. Science tells us the water comes to a full boil at 203 degrees Fahrenheit at 5,000 feet above sea level. Let me tell you what those temperatures have meant to me. When I have prepared in the past the kind of meals AT hikers often eat, whether I prepare those meals at home or out in the woods, if I use a high water temperature, 3 times out of 4 what I've done is I've either burned the food or boiled over the pot. Now clearly that kind of cooking requires an attention span I apparently don't have, and I found out that if I back off the water temperature well below the 212 degree boiling point, the cooking process might take a minute or 2 longer, but I don't burn the food and I don't boil over the pot, and that's why my first choice is to opt for a water temperature that is well below that full boiling point of 212 degrees Fahrenheit. Things like boiling raw potatoes or boiling eggs are of course a different story, but I've never done that on the AT. Eventually I began to notice some thru hikers seem to know exactly how much alcohol to put in their burner without even measuring it. They would pour some alcohol in and light it, and when the burner went out, no more burning was needed. Apparently that's how good you can get when you've been doing it every day for 3 months. I experimented with this later using measuring spoons. I found for the kind of cooking I did on the AT, I needed 1 tablespoon of alcohol, and 1 tablespoon, for those who don't know, equals 1/2 of a fluid ounce. That leads us to the question of how hot can we get water when using 1/2 of a fluid ounce of alcohol. To find out, I conducted a series of test burns, and every one I'm going to tell you about used 1/2 of a fluid ounce of alcohol. You can try these kinds of experiments at home. I can tell you I took pains to precisely measure the alcohol in the water used, yet I would end up from burn to burn with some variation in the final temperature. I did these tests indoors without wind, and I can only assume that 2 or 3 extra drops of alcohol will make a difference of a couple of degrees in the final temperature. For that reason, what I'm going to give you are the average temperatures I got. I used denatured alcohol for these tests. We'll talk later about what other kinds of alcohol can do. We'll start off with the Trangia because it is an example of what a sophisticated alcohol stove can accomplish. If I use the Trangia with anything from 10 to 16 ounces of water, I will get a temperature of 212 degrees or something very close to it, and it didn't matter if the lid was on the pot or off. This homemade stove is basically designed to mimic the action of the Trangia. Like the Trangia, this stove will achieve a temperature of about 212 degrees when using 10 ounces of water. On the other hand, if I used 16 ounces of water, this homemade stove would only average 180 degrees. How did that happen? If we put the same amount of fuel in the homemade stove and the Trangia and light them simultaneously, the homemade stove will burn itself dry first, and the Trangia will keep burning. To me, this demonstrates why the Trangia is really an outstanding alcohol stove, and if someone needs to get their water as hot as possible, the Trangia is a very reasonable choice. So what about an improvised open-top can? This can and pot holder with 10 ounces of water and a lid on the pot averaged 198 degrees. The tuna can and foil stove averaged about 5 degrees higher, around 203 degrees. If we look back at our chart, we see these temperatures are giving us considerable steam and multiple small bubbles. One thing you'll notice when you burn alcohol in an open top can is after about a minute or so, the alcohol gets hot and begins to bubble. Because what is actually burning is the vapor off the alcohol, this bubbling will create more vapor and increase the heat and flame coming off of the open can burner. Sterno, which I mentioned earlier, is a jellied alcohol, and you will not experience this increase in heat when you use Sterno. The denatured alcohol I used in these tests is essentially ethanol or grain alcohol that has been poisoned. Most outfitter stores near or along the AT that sell light gas by the ounce will also sell denatured alcohol by the ounce. Another very common type of alcohol is isopropyl. This is sometimes used in auto engine deicer, and it's also used almost exclusively in rubbing alcohol. In supermarkets and drugstores, I have seen isopropyl rubbing alcohol that contains either 91% alcohol, the remainder water, or 70% alcohol and the remainder water. With 91% isopropyl, I got essentially the same results I got when I used denatured alcohol. I found 70% isopropyl not as easy to light as denatured, so it took patience to get the 70% isopropyl going. I also found that if an open can burner would give me a water temperature of 198 degrees with denatured alcohol, the same burner would give me a temperature of only 178 degrees with 70% isopropyl. So if I want to get the same temperature as denatured, I would have to use more 70% isopropyl. Unlike denatured, isopropyl will leave some soot on the bottom of the pot, but it's nothing compared to what you would get if you were cooking over an open fire. Also, 70% isopropyl will leave some water in the burner when the fire goes out. I did not experience that with 91% isopropyl. Here's an old clip of me at a wooden shelter on the AT preparing a freeze-dried meal, and the dinky flame on my Esbit stove probably gave the water a temperature of somewhere between 190 and 200 degrees. Later, I abandoned freeze-dried food and started cooking my meals in my pot. I would typically use 9 or 10 ounces of water, giving me a water temperature of somewhere over 200. And this takes us back to the freeze-dried meal. The freeze-dried instructions told me to put hot water in and wait 8 to 9 minutes before I ate the meal. Having been accustomed to that procedure when I would cook in the pot, once the fire burned out or I removed it from the flame, I would let that pot sit for about 8 or 9 minutes. When I would first remove the pot from the fire, the food would not necessarily look done, but water tends to hang on to its heat, particularly in a pot with a lid on it, and after 8 or 9 minutes it would be done and it would look much like you see here. I can also say I have used this procedure in the winter, and if I can avoid setting the pot in the snow for that 8 or 9 minute wait, the results are very much similar to what I would experience in the summer. Some people make a cozy for their cooking pot, which is essentially an insulated cover that could be put on the pot for that 8 or 9 minute wait. I can certainly see where a cozy would be an advantage in some environments and some low temperatures, but I have yet to encounter the kind of conditions that would motivate me to make a cozy. So let me give you some tips if you ever need to make an expedient stove like this on the AT. For a burner, the bottom of a soda can will work as well as anything. It's very light and easy to work. If you make 2 of them, you can use one as a burner and the other to snuff the fire like this. This should work with just about any pot holder you would come up with. And speaking of pot holders, I have scoured supermarkets looking for something that would make a very handy pot holder for an expedient alcohol stove. The option I liked the best is an aluminum bean dip can. A cheese dip can, of course, will work fine. This particular one has a diameter of 3 1/4 inches, so any pot roughly 4 inches or more in diameter will fit on this thing very handily. The bean dip can be cut fairly easily, but it will hold a lot of weight and you don't have to worry about crushing the thing. This one was made with 2 large openings cut in the side. They were positioned in a way so that one side of the can has no opening at all. This can be placed upwind to serve as a windscreen. The metal can be cut pretty handily with any small knife or multi-tool. I have found that with one of these plain can burners in any pot holder, I need at least 1 inch of space between the top of the burner and the bottom of the pot to give the alcohol flame enough air to burn. To accomplish that with the bean dip pot holder, I cut a burner that was about 3/4 of an inch tall. Heavy aluminum foil cookie sheets, sold at almost any supermarket, can be used to make the kind of pot holder my thru-hiker friend had. Compared to my friend's tuna can, I would prefer the bottom of a soda can for this rig, because that would allow you to bend the aluminum foil to accommodate both small and large pots. I would fold that aluminum foil over double before cutting it to size to make sure it's sturdy enough to hold up a pot. Notice also the open end of the foil pot holder is about 2 inches wide, and the opposite side, which is enclosed, can be a windscreen. Another good option for a pot holder is a metal Esbit box stove if you happen to spot one in a store somewhere near the AT. So what do you do if you want to measure 1/2 of a fluid ounce of alcohol into your burner and you don't have a measuring spoon? I can tell you what I would do. These bottle caps from plastic Coke and Pepsi bottles hold just a little under 1/4 of a fluid ounce each. That does not mean I would use one of these caps to measure alcohol. Instead, I would use one of these caps to create a fill line inside my alcohol burner. If I put 2 caps of water in my burner, that's probably 90% of 1/2 of a fluid ounce. So I would add another splash or 2 of water. I would take a pocket knife and put a scratch at the height of the water inside that can. Then I would ditch the water, of course, and when it was time to cook a meal, I would put alcohol into the fill line I created inside the burner. And after cooking the first meal or 2, if I happened to decide that wasn't quite enough, I put another scratch in just a little bit higher. And with that, we're done. If you have to use these tricks sometime, I hope it helps. As always, thanks for watching.